thank you everybody for coming today. We are going to be doing the beginner Unity tutorial. This tutorial will be recorded and you can access it through the Discord for the Game Jam. This year, my lab, HCI for Good, and ShiftKey Labs are starting the annual tradition of the Global Game Jam for 18 plus and Game Jam Next for under 18 this weekend, Friday, February 3rd, all the way until Sunday the 5th. And all the participants are tasked to design a game in 48 hours. If you're not signed up for the Game Jam yet, capacity is really getting there, so please sign up soon. To help, we are fortunate to have mentors like Ben, who is actually going to give us this introduction to Unity tutorials. Ben is a member of Ubisoft Studios, which probably everyone has heard of. They made the Far Cry series, the Assassin's Creed series, Tom Clancy, Watchdog, Rayman Legend, and others. So thank you very much for Ben. Please take it away.
Sure. Let me thank you for that intro. Please hold on with me for 1 sec as I share my screen here. Right. Hopefully you can all see that at this point. Welcome everyone. Hopefully you're participating in this year's Global Game Jam. My name is Ben McElmile. I'm a senior programmer currently at Ubisoft Halifax. I've been with the company for about 6 months or so right now. And before that, I actually worked directly with Unity for about 2 years before that. So I've definitely been in the AAA, or I guess like big leagues, if you will, of game development for a little bit now. And I probably did 5 or 6 years of smaller but professional indie dev before that. I've always been a huge proponent of game jams. It's where I got my start doing a lot of my work. You'll learn more in a game jam over a weekend than you probably would for like months at school. And I don't say that to belittle any of the faculty here. I myself taught as well. But getting that real world hands-on experience with a team, you'll learn so much about yourself. So we only have an hour here today, so I am going to have to move pretty fast with everything. Most likely, if you haven't downloaded Unity already at this point, I'll show you how to get started and how to do that. Today's presentation will be as if you've never used Unity ever before, but I will warn you now, what we're able to make within that hour is going to be very simple. That said, I do have some really useful resources that I'll share with everyone at the end. Unity has a great system called Learn, or a great resource, I should say, called Unity Learn. It's got, I don't know, thousands of hours worth of free content, all the way from beginner things like I'm going to recommend up to advanced topics, creating shaders, pretty much anything you could want. So I'll share that at the end. So let's get right into this. Hopefully you're not hearing sound right now, so I can talk over this video. But this video itself is straight from Unity, straight from the horse's mouth, if you will. And it's just kind of a demo of some of the games that we've seen created in Unity in the last few years. Unity itself is a game creation engine. So it's really a piece of technology that allows you to take your vision and create your game without having to write everything from the ground up. I don't know, I'm sure a lot of you are probably just getting started with game development. You haven't been doing it for a long time, and you're really fortunate. We have tools like Unity or Unreal, Godot. There's a bunch of different engines out there that enable you to get your game, I guess, out of your mind and onto the page or onto the screen, I suppose it is, without having to write everything from scratch. Back when I started in game development, it was all C++ proprietary engines. Just to get something simple like a character on screen would literally take days worth of work. You'd have to create everything in C++ and OpenGL or something similar by yourself. These days, as you'll see in a few minutes, it's really a lot of it's drag and drop. If you have a 3D model, if you're working with an artist, or you can find lots of resources online, you can literally drag them into the program, hit play, and it's good to go. So we used engines like Unity or Unreal, Godot, like I said, to be able to do that. So what you're seeing here is a bunch of the more recent games, like I said. As you can tell, you can make games in 2D, 3D, a combination of the two. It's really more about your skill set and what you're comfortable doing. The technology at this point is pretty impressive, and particularly for a game jam. I really doubt you're going to hit the technology limits of the engine within 48 hours. If you do, we should definitely talk, because you're doing some pretty impressive stuff. But that's enough about actually just, looking at slides. Let's get into this, because there is quite a bit to get to in an hour. So if you've never used Unity before, good news is it's free. It's free for you as students. It's free for you even as professionals. I think it's up to, and don't quote me on this, I haven't worked for them for a while, but I think it's up to the threshold of $100,000 US per year that you're making. So if you're creating indie games and you're putting it out there on Steam or wherever you are putting it, you can even make money before they really ask for any money in return, which is nice. So the first thing you want to do is come to unity.com. And You'll create an account in just a second, but for the sake of time, I want to get you all downloading the software first. So when you arrive on this web page here, you'll see this blue button, Download Unity. Go ahead and click that, and it should bring you to another page, another blue button, Download for Windows. If you're on another machine, if you're on a Mac or something like that, you can download it for whatever. But I'm on Windows, so I will click this, and you'll see it starts downloading Unity Hub. Let that download. I already have it installed, so I'm going to cancel it, but we'll let that get started in the background for everyone. While that downloads, up in the top right corner, you'll see one of these default avatar type icons. Go ahead and click that, and you'll see create a Unity ID. So Unity, just like pretty much every other software these days, requires you to have an ID. You can come in here. I'm sure you've all created multiple software accounts at this point in your life. This is the same as any of them. Fill out your email, your password, create a username, all that kind of stuff. You should read over the terms of, and agreements, and create your Unity ID. Pretty straightforward. I'm sure you've all done this stuff before. They will send you a confirmation email, so check out for that after you've signed up here. And then hopefully Unity Hub has downloaded in your background. I know for everyone it probably hasn't, but again, because of restraints of time, I'm just going to pretend it has, and open up mine here. Now, if there is anything you don't get today, if you're trying to follow along, I will be going pretty quick. I do have the entire project I'm making today in a GitHub repo I can pass out. And if you do have any questions after as well, I will be on the Discord the entirety of the Game Jam weekend, and even before. So if you want to message me over there, please feel free to. So I'm going to pretend that Unity Hub has downloaded for me, and I've gone through the install process. A window will pop up, just like any installer you've ever seen. You can pretty much just pick where you want it to go, keep hitting next, and it will install Unity Hub for you. Once you have that installed,
You muted yourself.
thank you for that. Can you hear me now? I'm not sure how I did that one. But this is the first Unity official software we're going to see. So Unity Hub isn't the editor. Instead of that, it's a container that enables you to keep track of all your different projects. You might have different versions of the editor. When I say the editor, that's the software we're going to see in a second that actually enables you to create video games. Yours won't look quite like this. I have a bunch of different random projects in here. Yours will just be empty, but you should have this screen itself. So Unity Hub, again, it's not the editor. It's just like it's like Steam would be is a good example, where it's kind of the hub where you have all your games listed, and then you can upgrade your versions of whatever game you're playing, select different libraries, do a whole bunch of stuff like that. To actually get the editor here, you're going to want to come down to installs. So over here on the left-hand side, you'll see installs. And they'll have a whole bunch of different versions that you can grab. For the purposes of this demo, any of them is fine. If you already have Unity downloaded, any version's fine. What we're doing today is really simple. But if you don't have one at this point, what I would recommend doing is grabbing the latest version that you see has LTS. So you'll see that some of them here, LTS, what that stands for is long-term support. So how Unity works is they constantly iterate on the software. I think it's every week or maybe every 2 weeks they put out a new, at least a minor version or a patch version of the software. So it's constantly being upgraded. And we can tell you from experience, if you're starting a project and you try to upgrade every single time, it's going to create more issues than it's worth. And that was kind of the process that Unity started recognizing. So what they do is every year, I guess they kind of go through an iteration process, if you will, or what they call the tech stream. So as they're coming up with new features, they're adding new things to the software. That'll be in the current year's version. So we just went to 2023, so we don't have a 2023 version yet. But you can see down here, we have the 2021 version. So it's kind of like 1 year ago, more or less. Once that year is complete, they kind of package that all up and give us that long-term support. The idea being that that's the most stable version you're going to get. They're not adding any new major features at this point. It's really just like bug fixing and making it stable for everyone to use. So I suggest grabbing whatever your latest LTS is. So it looks like right now it's 2021.3.17F1. But again, doesn't super matter. Any version will do. So this will, again, once you start downloading this, it will take a while. And again, I'm going to skip by that. All you have to do is select the one you want, hit install editor, and it will start downloading for you. Now, while we are here in this hub part, before we get into the main meat and potatoes, if you will, I do want to bring into your attention some other useful tabs over here in the side. So I already quickly mentioned Unity Learn, and this is a great spot. I'll click it here. This is a great spot if you've never touched Unity before, or if there's some specific thing you want to learn more about. You can open this and you can see all the different course offerings. Now, Unity Learn itself is like a website. It's like a collection of lessons you can go through. And the one I really recommend for anyone who's just getting started, you've never used Unity before, is this Create with Code. I actually personally had a hand in running a few of these sessions when I was at Unity, and it's a really good course. If you want to see, you can just scroll down and see some of the other stuff they have. But you can also visit Unity Learn here. And I'll pass out this link at the end as well, so don't worry about getting it right now. But on this website here, you can see all kinds of great lessons. It'll tell you roughly how long things will take. This Create with Code course, all of the sub-modules of it, it says it's 41 hours. I've never seen anyone take anywhere near that. So don't be scared by that. Realistically, if you go through this Unit 1 player control, it says 7 hours. Most people do it under 1. So don't be freaked out if you see these and think you don't have time before the jam. I definitely recommend checking these out. But let's get back to it here. Back in Unity Hub, I want to go back up to my Projects tab. This is the first tab we saw when you open Unity Hub, and it's the default screen you'll get going forward. And I want to create a new project today. So I'll hit that new project button. And here's where you'll select, it should be auto-selected, but that whatever version of the editor you had here. So you can see for me, there's a whole bunch of different versions. I've worked on a whole bunch of different projects, so I have a lot installed. You'll probably just see one up there. Now, when we first start a project in Unity, you have the option of templates. And this is really just like, hey, we're going to help you out a little bit and set up the editor in a way that hopefully will make the workflow for whatever project type you're doing a little bit easier. So if you're thinking about the upcoming game jam and you know you want to do a 2D game, I suggest you select 2D core. Same thing, hey, I want to do 3D work, probably select 3D. If you do say, I don't know, you have an idea about a 3D game, you start your game there, maybe halfway through the jam or something, your artist is like, you know what, this would actually be way cooler with 2D art. You can change after. Everything that's going to set here in the template is optional, and we can toggle it after. So, don't stress out. You're not choosing the right thing. Pick what you think makes the most sense to you. There is a whole bunch of different types of projects. I won't go through them all here today. But again, if you're new to Unity and you're looking for a little inspiration, if you will. They have some interesting ones like a first-person 3D game, third-person games. They have some Lego games, first-person shooters, karting games, stuff like that. If you click it, it's actually a project you can open up and start playing with. So again, it's a really useful resource. But for us today, I'm just going to create a 2D core game. We're going to create a really basic 2D project. So I will create a 2D core. And then over here on the right side, we have all of our project settings, or at least the ones we get to create with. So we'll have a project name. I'll call this something like Global Game Jam 23 Demo. The name is just a name. Doesn't matter, whatever you want to call it. And we also have a location. This is just where you want it to be on your hard drive. So I'll come in here and create a new folder as well. I'll call it something similar. Again, this is just whatever you want to call it. So there we go. And after that, you're going to hit Create Project. Now, this is going to take a few minutes to spin up. This is the Unity editor, the editor itself opening up. The first time you do this, it's loading that template and getting everything set up. And depending on how fast or slow your machine is, this can take anywhere from like 30 seconds up to like 10 minutes. It also depends on what template you chose and how much it has to import. I think I did this earlier for this template on my machine. It was something like, I don't know, 3 to 4 minutes. And I don't want to just sit here waiting for the screen to load. So through the magic of editing, I should have the Unity editor open. So again, I apologize if you're trying to follow along and things are taking slow, but we do, things are going slow, but we do have limited time. So I'm just going to kind of keep chugging along. So what you're seeing here is the Unity editor itself. This is when people say Unity, this is really what they're referring to, this editor here. And you can see we've got a whole bunch of different windows. It might be a little bit overwhelming at first, but let's go through this a little bit. So this main window you see right here in the middle of the screen is probably the most important. And right now it's set to the scene view. So a scene, you can kind of think of it like a movie would be. Like we set up a scene and we have a bunch of actors inside of it. Maybe there's lights and there's cameras and whatever we need for our game to play, everything's going to live within the scene. So right now I don't have a whole lot going on. It's just blank. There's a grid you can see in the background. Hopefully the sharing resolution is high enough to see that. I can zoom in and out using my mouse button, and I can move around. I can hold my middle mouse button. I can slide stuff, but again, there's not a whole lot to see at this point. You may notice though in the middle here we do have a camera icon, and I can click that, and you'll see some stuff changed over here and some stuff changed over here. This camera I just clicked on is our first example of a game object. So everything in Unity that lives in a scene is considered a game object. This doesn't matter if it's the camera you're using to show your scene. It might be a lighting source. It might be a 3D model, a character. It might not even have anything visual you can see in the actual game. It could be something like a physics, like a collider, like an empty physics object. It could just be something that has a few scripts on it that run in the background. It's really just the kind of the highest level object type we have in Unity. And when I clicked this camera button here, you'll see over on the right in this window that we call the inspector, a whole bunch of things changed. So before it was just empty. When I clicked it, it showed me all the values of this game object. So this camera game object here, we'll go over this really quickly. There is a lot to it, but we'll just try to give you the highlights of it, if you will. The first thing you'll notice at the very top is we have this naming box. So this is the name of whatever game object I just clicked. In this instance, it's the main camera object. We won't go over tags because we won't need that for today. But the transform component is really important. So the first thing we had here with the name up here, that's on every single game object. Every single game object will always have that name component to it. But then I have some things I can collapse here. And every game object, like I said, can be different. It could be the camera, could be the 3D model, could be some music that plays in the background. Whatever we have on that game object, these are called components. So by default, every game object has this transform component that I just closed, and I'll reopen it here. And this describes the game object's position relative to 3D space. So even though we selected a 2D game, Unity is always really 3D under the hood. And in fact, I'll kind of show you what I mean in a second when we add some things to the scene. But we have base information about the position of this main camera in our scene. So I can see it's at, this uses an XYZ coordinate system. Every game engine will use that. Definitely, if you don't remember this from like high school or something like that, like your X and Y and Z graphs, it is something that's core to any game dev experience, and you should definitely brush up on that knowledge. So for this, it describes the position of the camera. So right now it's at X0, Y0, and Z -10. The Z axis or Z axis doesn't matter quite as much in 2D, but if we're in 3D, it obviously has a large effect. That's the depth, so how like far in and out something is. We also have the rotation of an object, again, on the X, Y, and Z axis. Right now, we're not rotating, it's all set to 0. And we also have information about the scale of an object. Now, a camera, I mean, we can change the scale, but it doesn't really do anything. But when we add something like a model or a 2D sprite, we'll see it does stuff there in a second. So every single game object you have in Unity will always have this transform element, or component, I should say, that describes its position relative to the scene. After that is where we get into the special components based on what this object is doing for you. So in this instance, it's our camera, so we have a camera component. Now, I won't go over all what's in here because it's really not that important to today, but you can see some interesting things like the background color. You can actually see down here in the bottom of the scene view is what the main camera is seeing right now. So when I'm in this scene view, it looks like it's gray and I can kind of see that grid in the background. That's really just for us as developers to line stuff up or snap things to the grid. But what the camera is actually seeing right now is the game view. So within this same window here, in the middle of the screen, you'll see I have a tab at the top that says game. If I click that, I get to this blue, rather boring screen, but this is what our camera is actually seeing. So again, we don't have anything in our scene yet, but when we do, this is what we'll see. So scene and game view just up here, those are really important. You're going to toggle back and forth a lot. but for the most part, we work in scene view, and when we play our game, we then see and interact with the game in game view. So this camera right now, just to give an example of how we can change stuff. Let's say I want to change the background color of this to, I don't know, I want it to be black or gray or red or whatever color it is I want it to be. I could just go in here and use this color selector. Sorry, clicked off there. You'll see the background is now black, and if I go back to my game view, it indeed is black. So not that exciting, but we're getting somewhere. The rest of these settings I'm not going to go over today. We just don't have the time. And honestly, unless you're making anything fancy and you're just a beginner, you probably don't need to know them. Then we also have an audio listener, excuse me, which doesn't have any other properties to it. This is really just like your ears. You can imagine you have your camera, and there's like, a camera operator running around a scene, if you will. The audio listener is kind of like having microphones that act as our ear. And this is important that it is on the main camera, in particular if you're doing a 3D game with spatial audio. So like maybe you're doing a shooter game and there's some guy over to the right of you shooting at you, and you want to be able to tell where he's coming from. The position or what game component this audio listener is on is important because it has to be relative, I guess, to where it's happening. So if you think of the camera as our eyes that we're seeing into the game with, we want that listener to be on us so that we can hear that guy shooting off to the right, or an explosion or wind or whatever happens to be going on. So over here on the left, that was our, oh, sorry, on the right, that was our inspector. On the left side of the screen over here, we have the project's hierarchy. So right now, our scene is really simple. It just has that camera in it. We can see we have the scene is called sample scene. That's the highest level of our hierarchy. And next to that is that game object we were just looking at called main camera. So as we add more component or add more game objects to our scene, rather, we'll see them added to this hierarchy list over here. We'll be able to change things around, and we'll get the flow when we get there. Down here on the bottom of the screen, we have the project window. I guess there's two tabs, project and console. The console, I assume most of you are probably into programming or have taken at least some kind of comp sci course at this point. It's just like the console you'd see in any programming application. You can print things to it, debug information. You won't have this console when you actually build your game and someone's playing it on Steam. This is really just a debug tool. So it is handy though. Let's say you're like, hey, something's not working right. I expect these two cars to crash into each other, but the math is wrong or something. Maybe you print out information about the collision or the force or something like that. So it's useful to know where this console is. Also, if you start getting errors in your project, which you almost certainly will, that's the bane of every programmer's existence, is that we always create bugs and errors. Those will be printed down here as well. So if you go to hit play and something doesn't work right and it says error, this is where you're going to want to come to check out what's going on. That other tab that we started with here is the project tab, or the project window. And this is where we have all the different assets that we call them that make up our game. So assets can be anything that our game is created from. So 3D models, it could be the textures that go on those 3D models, the music we use in our game. It could be like text files. Maybe you have information about the levels, like you're saving them as a text file or a JSON file. Really, anything that goes into your game is considered an asset, and that will all live down here once we start bringing some of that information in. Speaking of which, let's add something to this game. So in preparation for this demo today, I have created, where do we go here? I have two sprites for us. So sprites are really just like 2D images. We call them sprites in games. That's all you really need to know right now. And these images I have today is just a little spaceship and a meteor. So I will pass out this link. You can download it. It's really small. It shouldn't take too long. I hit download, but I wanted to do get link. And I will put it in the Teams chat here. So feel free to download that. These assets that I've used here come from a resource that I'll share at the end as well. Kenny Game Assets literally has hundreds, if not thousands, of free assets you can use. I don't know the rules for Global Game Jam, so I don't want to say you should use them because I'm not sure if you're allowed to or not. But if at any point you're working on a project or you're prototyping something, or even during Global Game Jam, let's say you have an idea, you're like, hey, I just need a character until my artist completes the actual one we're going to use. It's a great resource to have to just grab and throw something in to prototype with. So these come from them. They're completely open source. You don't have to give credit. It's a great website. I'll link it here at the end. So if you went ahead and downloaded that, I'll go to my downloads as well. You're going to want to extract these. And then, like I said, it's just two PNG files. Nothing too special there. What I'm going to do, though, is highlight both of them and drag them down into my Unity instance. There's multiple ways to do anything in Unity. I like to personally drag them. You can directly input them. There's a whole bunch of things you can do. But you'll see here, I just imported both of them just by dragging and dropping. That was it. So I took that. Again, a lot of people missed that the first time. I just took them, dragged it down to my Unity window, and then I dropped it down here in my assets. And then after that, I have these two assets that are ready to be used in my game. It's really that simple. So this would work, again, if you're using 2D sprites, 3D models, music, anything like that. It's really just drag and drop it down here into the assets. So let's actually get these into our game and we'll start seeing something here. So to do that, again, all I'm going to do, I'm down here in my assets. I'll drag it up into my scene view and I can just place it wherever I see appropriate. So again, just drag and drop. So all you got to do. I could create two of them if I wanted. Just drag and drop. Let's check out this spaceship a little bit. So I just drag and drop it, and Unity did the rest. This is really the power of using an editor or an engine like this. You're not writing code to do this. You're not writing like a sprite renderer, the code that actually draws this to the screen. You're not touching graphics cards, anything like that. Drag and drop, it does the rest. So when I did that, we'll notice over here in our hierarchy window, before we just had our main camera and it was just the main camera, I should say. Now we have this new spaceship game object. So again, everything that lives in our scene is always considered a game object, and it could be that camera. In this instance, it's a sprite or a 2D image. If I go over to the right window here, the inspector window or inspector panel, again, you'll see I have the name of that game object. I have the transform, which describes where it is in my scene. And then this time, the other component I have is a sprite renderer. So like I said, every game object will always have this name and tag information. It will always have this transform information. And then after that, the components tend to vary up depending on what the game object's doing for you. So this is drawing a sprite or that 2D image to the screen, and therefore it has this sprite renderer component. You really don't have to worry about anything that's in here. Just know that this is what the code behind the scene that's actually drawing this object to the screen. Now I want to make a little bit of like a Flappy Bird type game here today. We'll see if we get into physics or not. I don't know. It's going to be pretty tight on time, but I'm going to drag up a meteor here. And what I want to happen is this meteor to be like, I guess, the bad guy or the thing, the obstacle I'm trying to avoid. And what I want to do is have it start over here on the right and go across to the left of the screen. And then I want the player to control my spaceship to go up and down to try to avoid hitting these. So it's about as basic of a game as you can get, but whoever created Flappy Bird made a ton of money off of it. You never know when something's going to take off. So, maybe you try something. Who knows? It's all about learning, right? So when I dragged that meteor up here, again, just as a quick review, it added that game object called meteor. Unity is not smart enough that it has some AI that's detecting what's actually happening here on screen. It's like, oh, that's a meteor. You'll see that that's just the name of the game object, or the name of the file, the sprite I brought up, and it just gave it that name by default. But again, it created that game object, it has that sprite render, and it has the transform. And this is a good instance to show what the transforms, I guess, kind of representing or kind of doing. If I set this meteor's transform position to 0, 0, 0, it goes to the dead center of our screen. It goes to the origin point, as we sometimes call it. I can either manually change these numbers just by clicking on them, and maybe I type in like 5 or something like that, and you'll see it moves over on that grid 5 units. So it's 5 units over. Same with the Y. If you remember back from like high school math lessons, the Y-axis goes up and down vertically. So maybe I put something like 2, it will move up 2 units. Or if I did something like -2, it would go down 2 units. Now we do have that Z or Z axis. You can see I can take it and I'm moving it right now, but nothing's really happening. At some point it did disappear. That's because we're making a 2D game and we don't really worry about depth. But if you remember, I said Unity is always kind of 3D. It just kind of gives us this fake 2D illusion. I can actually demonstrate that right now, and this is kind of mind-blowing. I have this little 2D icon here. Usually you don't have to touch it too much, but you can see with just a click of a button, my 2D scene did turn into a 3D scene, which is kind of cool. And you can actually see there's the camera in 3D space. And when I move that Z axis on that meteor, it is dragging it back and forth. And if I go back to 2D for a second, when I went too far on the where were we? There, if I dragged it too far on the Z-axis, it disappeared. What's actually happening? Sorry. If I go to this, you'll see it's gone way behind the camera now. The camera's facing over this way, and it's essentially gone behind the camera, so we can't see it. This is important. You use that access in 3D games. 2D games are not really that important. I did want to just point out though that Unity is technically always 3D, even though it gives the illusion of that it's not. That does give you the ability to do some pretty cool things though. You can make like I've heard different phrases, but like 2.5D games where you have like 2D sprites navigating a 3D world. I've heard it called HD 2D or 2D HD or something. There's a few different terms for it, but you can mix and match styles. And especially in a game jam, it's a good time to experiment, and you can come up with some really interesting looking things. Maybe you have an artist that's an experienced like 3D modeler, but then you have an artist that's only ever done 2D sprites, and you're freaking out like how are these people going to work together. You can actually use that and create really interesting styles in your games. You just really have to get a little creative with it. But back to our demo at hand here today. So I said that I want my meteor to come from the right of the screen and go by my control or my player, my spaceship on the left. And if I just sit here and drag it, it makes for a really boring video game. It's not exactly interactive for anyone but me. So I want to start programming here a little bit. And I want to start by having these meteors come from the right of the screen and moving over to the left. So we know if we're doing this manually, like I'm doing right now, when I'm dragging it around, we're seeing this transform's position being moved. And of course, I'm doing that manually, but now we want to switch to doing that programmatically. So to do that, we're going to create our first script. So Unity uses C# as its scripting language. The engine itself is C++ under the hood. But anytime you're writing anything that like and any programming or anything code-wise for it, it's always going to be in C#. So to do that, again, there's multiple ways to do anything in Unity. So if you have, another way you like to do this, by all means, use that. But for me, the first time doing this, what I like to do is come down into the project panel down here, and I like to create a folder. You don't have to do this. So I should say what I just did right there. I'm down here in the project window. I right click. I get this little like toolbar or toolbox, whatever you want to call it, that pops up. And at the very top, I get create. And I'm going to go to the very top of that and get folder. So this is just like creating a folder or a directory on your machine. Same thing's happening here. In fact, it's doing that under the hood for us. Doing that, I will also say, I'll name it scripts. So this is, like I said, C#, and all of our C# scripts are going to live in here. And just to keep our project clean, I suggest you do that you create a folder for every asset type you have. So earlier I just dragged and dropped these two sprites I had, and you could just put everything just on this level, but just as if you were making any other project and any, you're making a C++ project in Visual Studio or JavaScript or whatever, you probably want to organize things just to make your life easier down the line. And that's definitely the case in video games. Speaking from experience, you get into massive AAA type projects and you will have literally hundreds of thousands of assets. And if you just have them all at one level, it's going to get a mess real quick. It's going to get a mess no matter what, but try to make make your life easier down the line. So I'll right click, create, and create another folder here. And this time I'm going to name it sprites. And again, a sprite is really just a 2D image. It's a fancy word us programmers or video game developers like to use. But all I will do at this point to put those in there is drag it and drop it into the sprites. Again, purely for organization. You don't have to do that. It'll run exactly the same, but good idea to do that. So back to scripting. I'm going to go into my new scripts directory I just created. And then again, I'm going to right click. I'm going to go up to create, and I'm going to go this time to C# script. So again, always C#, and I'm going to click that. And then I get this little, you call it a hashtag or a pound sign if you're old like me. That's just a visual representation of our C# script. If you've never used the language before, it's like C and sharp, as in like a musical sharp. That's why we use that little logo. By default, it's going to be called new behavior. I want to change this again just for organizational sake. I want it to represent that meteor. This is going to be the script that controls the meteor for me. So I will simply call it meteor. Nothing too fancy there. And then I'm going to double click it to open up Visual Studio. So when you were first installing the Unity, I kind of jumped through that quick today, but it does give you the option to install, I think it's Visual Studio 2019 Community Edition. I might be wrong, don't hold me to it, but it will install one of the latest community editions of Visual Studios. And it should set it up for you so that it's automatically connected. Obviously, Visual Studios is not directly part of Unity, but you're going to use it as your main IDE. It's the main thing you're going to be programming in, just like it is for a lot of programming applications. So you'll see here, it's opened up Visual Studio for me. It's created a public class with the name of that script I gave it earlier, so Meteor. You'll see it inherits from mono behavior. This isn't, a programming lesson or lecture per se, so I'm not going to talk about inheritance, but it is important to note that what's in this mono behavior class that's really core to the Unity experience is a bunch of really useful function calls, which it gave us two that we most often use. The first function here we see is the start method or start function. And this is called, like the comment said, before the first frame updates. So really this is just when I hit the play button, which we'll do here in a few minutes, as soon as my game starts, any code I put in this function, it will get called right away. So maybe I want to like load a level or I don't know, load some kind of assets or something like that. Most likely you're going to want to put it here. The other function it gives me is the update function. So this is really like the bread and butter of the Unity experience. Everything that we do when we see the game actually running will live somewhere in one of these update calls. And this is called once per frame. So the way video games work, I'm sure at some point you've all, probably made like a flip book or you've seen classic animation of like a Disney movie or something where we draw what we call frames. I'm sure you've all played games at this point. Most likely if you're here and you get like frames per second, this is really what this is coming down to. So we're drawing like an image and we draw enough of those images within a second really quickly after each other that it looks like it's animated. But realistically, we're just drawing a whole bunch of still images and flipping through them really fast. Just like they used to do it with old movies, except for, these days we do it at 60 FPS or probably a lot more realistically. So anytime we want one of those frames to be drawn, it will call this update function, and then whatever we put in here will be calculated and executed before that new frame is created. So for us, if you remember, what I'm trying to do is have my meteor go across the screen. This is one of the pains. Once you start opening Visual Studio, you'll get that loading window a lot. But that's just the way it is, unfortunately. But if you remember, I had this meteor and I wanted to have it go across my screen, in this instance, from right to left. So somehow through code, I want to touch this game object's transform. And luckily, again, through the power of the Mono behavior class, we have the ability to use that transform. Now, this is where there isn't really any good way to do this outside of experience, but mono behavior has a whole bunch of potential methods and properties that we can use that you just have to learn about over time. There's a lot of documentation about this as well, but for today's sake, I'm just going to start using some stuff and explain it as we go. So in this update, I want to use our transform dot position. Oh, and I used the wrong transform, I believe. Here we go. And what this is going to do is actually give me what we call a vector 3, which is really just 3 float numbers or 3 numbers that represent, keep clicking the wrong thing, that position we had here. So you can see these are just 3 numbers, an X, Y, and a Z. That's what we call a vector 3. It's really just an X, Y, and Z pairing. And what I want to do with this is update it. So I want this transform position to equal. And what I want to do is take wherever that meteor currently is and just subtract a little bit on the X value. So we're moving it across the screen horizontally. And I want to move it a little bit to the left. So I'm subtracting an X value to that. So what I'm going to do is set it back to this transform dot position. And then I'm going to subtract from that a new vector 3. And again, I apologize if you haven't programmed much in the past. This is probably already getting really confusing. But just for the sake of having something move, I'm going to kind of go along quickly here. So I'm going to get this to move at 1. I'm going to subtract 1 unit on the x-axis. I don't want it to move up and down at all. I want it to stay where it is. So I'm going to set that to be 0 on the y-axis. And then same thing on the z-axis. It's a 3D game. We don't tend to use it very much, so it will be 0 as well. So again, quick review of what I'm doing here. I have my transform position. I'm going to set that, so set where the object is currently to its current position minus 1 on the x axis. And I keep clicking the wrong thing. Let's go back to our game here. We let it load because that's what it likes to do. And how do we actually get to see what's happening? Well, you'll see up here at the very top, we have a play button, we have a pause button, and a next frame button. Feel free to click it, but we're not going to see much happen yet. We are going to see it switches to our game view. We have the setup we had, but we're not seeing it move. Why not? Well, we wrote the code for it to move, but we actually haven't applied that script to the object itself. So we know we want this meteor here to move, and we created the script for it. What I'm going to do is take the script and drag it and drop it onto that game object. And you see, I should say, what I just did was drag and drop it here. Again, Unity has a million ways to do anything. I could have done an add component and then looked up the meteor class. It really comes down to just whatever you're comfortable with. But the main thing to take away is our game object that represents the meteor here. It now has our transform, it has that sprite renderer, and it now has this script. This is a new component that we just added to it. Now, when I hit play this time, oof, that meteor was going real fast, but it definitely moved. It went by. I don't know what the refresh rate of zoom is. Maybe you didn't even see it move at all. But where the heck did it go? It's kind of gone. I'm going to leave the game running and go back to my scene view. And what I can actually do, I'm going to hit pause here. So this is pausing the game on the current frame it is. If I double click my meteor, it's somewhere over here. But if I zoom out, there's my spaceship, and it's gone flying way, way past it over here. Somewhere to the left. It's at negative 5,500 something. So it definitely worked, but it's going a little bit fast. And we've also introduced a bit of an issue here with our code. Let me go back to it. So I said, hey, I want this to go -1 units to the left. It would be on the x-axis, but I'm not. And I said I was just talking about frame rates, frames per second. By default, Unity is going to try to hit 60 frames per second. So if we do the math and we know that this is called every frame, it should, in theory, move roughly 60 units to the left. But if any, and most of you, I'm sure, are gamers to some degree. Maybe this is running on your phone, and if you're getting really bad performance, this is a really simple demo, so it wouldn't actually do this. But let's say you're only getting 10 frames per second because you're on grandma's old flip phone or something like that. And then let's say the guy next to you is playing on his monster PC gaming rig, and he's getting like 500 frames a second. That's really going to break our player's experience, because if we're playing on that, grandma's old phone, then our game is essentially moving really slow. Every second, that object's only moving 10 units over to the left. But if I'm that, high core elite PC master race player, then all of a sudden my game's moving way, way faster. And it's actually creating a very different experience for those two players. So we need some way to kind of average that out. We don't want it to be based on how many frames you're getting. We want it to be based on times. We want to say, hey, this should just move 1 unit per second, not 1 unit per frame. So Unity also has that built in for you. We won't talk about the math too much, but you can multiply it by times dot delta time. So what this actually represents is how much time in seconds there's been between the frames. So by default, the game will be 60 frames per second. So it equals out to something like 0.016 repeating. So when we do the math, it doesn't matter how fast or slow our machine we're running this on now. We should get a constant 1 unit per second movement of that meteor. So let's go back and see if it looks a little bit better for us now. Did I select the right one? I think I did. There we go. Okay, I'm going to hit play again this time. And we'll see. Okay, it's moving. It's moving over to the left. Maybe it's a little slow now, but at least it's not flying off the screen like we saw before. So this really comes down to just preference at this point. I can come in here and I can tweak this value to be whatever it is. Maybe I think I want it to be 5 or something like that. I'm going to leave it at 5, and we'll just call it at that for right now because we're running really low on time here. So we'll see that our unit is, or our meteor is just going over to the left of the screen. This loading is always killing us here. It's moving over there to the left of the screen. And right now, unfortunately, it's going to be gone forever. We're going to leave it at that for now, and we'll see if we have time to come back to it. But let's start working on our spaceship a little bit. Right now, it's just a stationary object. This game isn't interactable at all. It's more of a movie than a game, which isn't very fun. So let's create another script that's going to control our spaceship here. So again, I'm down here in the project panel. I'm going to right click and hit create. Go up to my C# script, and I'll call this one ship. Again, it's just a name. You can name it whatever you want it to be. It won't change anything about how it actually performs or interacts. It's good to have a naming convention, but that's about it. I'm going to drag this script onto my spaceship. So it's there. Again, you can see it added this, the script onto that game object. And then again, I will double click that class and we will see that our ship class is now here and available for us. It gives us this exact same template we had before. We have the start and we have the update function. This time what I want to do is instead of it just moving by itself, I want it to interact. When we hit the keyboard, it should respond and go up or down. So to do that, I'm going to just create a simple if statement. And again, it has, there's a whole bunch of built-in stuff from this mono behavior, one of them being input. So I'm going to do input dot get key down. Actually, I'll just use get key. And then you can put in any key you want. I find the easiest way to do this is you can use that built-in enum of key code dot, and then they literally have every key you'll find on your keyboard. You can just start using IntelliSense and do like arrow up. So this if statement here will just say anytime our up arrow is being held, do whatever we put in here. I'll also just copy and paste this and do down arrow, so we'll move down as well. So now we just have something listening for any time the player uses the up button on the keyboard, or the down arrow, I should say, do something. Let's put in that something now. So just like we did with that meteor, we wanted the meteor to move left to right using its position. We're going to do something similar with the spaceship. We want it to move up and down this time. And if we're hitting the up arrow, we probably want it to move up. So let's use the same thing, transform.position equals transform.position plus a new vector 3. This time we don't want it to move left and right at all. So we'll put in 0 for the x value. Let's make it move up at the value of 1 unit per second. And again, we don't want it to go front or back. We don't want any depth on this. So we put 0 on the x-axis. And then the same thing applies here. Anytime we're doing anything on the frame, we want it to be frame rate independent. We don't want that frame rate to matter to our experience. So we multiply it by time dot delta time. So this is just saying that, hey, anytime we're holding that up arrow, move that ship up 1 unit per second. Same thing, I'm going to just copy and paste it for the sake of time. This time, I want it to move down, though. So same thing, I don't want it to move left or right at all. I want it to move down, so I'll make it -1 units, and then nothing again on the Z. And we keep our time.delta time to keep it frame rate independent. Let's go back over to Unity at this point. Let it load here for a second. I do realize it's getting a little late here. I will try to save a little bit of time. I don't have to be gone right at 5 o'clock, so I can stick around and answer questions. And if anyone does have any questions, again, I will be available on Discord. We'll talk about that in a second. So it looks like this is ready to go. Let's hit play. And at this point, I can move my ship up and down. Now, Flappy Bird used physics, right? It always had gravity pulling down on it, and anytime you clicked on your screen or your mouse button, whatever it was, it would go up and down. We can and probably should add physics to this, but we're definitely going to run out of time, so I won't do that today. But maybe we'll do like another 5 minutes of programming. And right now, it's kind of lame because I just let the meteor fly by, and then I dodged it and I won, I guess. Not exactly exciting. We should probably have more than one obstacle coming at us. So to do this, I could just go in here and copy and paste a whole bunch of these and essentially make, like a million meteors. But that's going to be pretty intensive resource-wise. You don't really need to do that all the time. Instead, we can use a really simple programming or a game trick, I suppose. And you'll note here when I'm in the scene view, I have this white square or rectangle, I suppose, that's going around my game. That's actually showing me what the camera, what the view of it is. So these lines represent the edge of what the camera is going to see. So what we can do is something like this. When the object goes just out of frame over here on the left, let's just snap it back over on the right on that same frame. We're not going to use more than one meteor, but it's going to give the player the illusion that there's oncoming meteors going forever. So we're only ever using one. We don't have to worry about using too many resources. It's good for performance and everything like that. So let's see if we can do that really quick and add a little bit of random logic to it, and then we'll call it a day. So let's go back to our meteor script here. Under where we have it moving over to the left, I'm going to put in an if statement. And then I'm going to check the transform position dot x value of it. So what I want to happen is anytime the meteor goes just off frame, so we'll call it minus 13 for good measure, something like that, then I will snap it to positive 13. So let's do that through code. So if our meteor's transform dot position dot x value is less than minus 13, and you'll see I'm using, it might be weird if you come from other languages, but I put in a number and then I put an F after it. That F is for float. It's a float value. It's just a quirk of C#, if you will. You'll get used to it if you haven't used it in the past, but really it just says, hey, this is a decimal valued number. So if that position goes over there past minus 13, then I'm going to just steal this line. And I'm going to copy and paste it here. And I'm going to say, then you should set the transform's position to, and I don't want to have any reference to where it currently is. We're setting it to a brand new position. And we're also not going to be using time.delta time because this is like a one-time operation. It gets moved over one time. I'm not doing it every single frame, even though it's checking for it every single frame. It's only going to ever be called once every few seconds or however long it takes. And what I'm going to do is then set it to that positive 13 value. So, hey, if it goes off screen on the left, minus 13, just reset it over on the right, positive 13. Now, when I am in here, we have just enough time to sneak this in. Right now, I'm hard coding all these values, which is fine. Obviously, it works, but it's not exactly the best for a few reasons. One is you probably, especially if you're working on a team or something like that, you don't expect every designer or every artist to always have to come into your code and create and change things. Probably as a coder, you don't want them in your code messing stuff up. So rather, you should probably have something publicly exposed so that in the editor, they can just tweak values without having to come into any code. That's the ideal solution. And we can do that by creating public properties. So we're going to create a variable here, a public float, and we'll call this one speed. And I'll set it to the default value of 5 because that's the value I had going down here. And I'm going to replace this hard-coded value of 5 with that variable I just created. Now, when I run it, it's going to look exactly the same, but I'll show you the magic of this. And then I think we'll pause for some questions after that. So let's see it running to begin with. So here it comes. It's moving over at 5 units per second. And if we've programmed this correctly, it's gone off screen and it's popped back. Now you will see it popped back a little bit higher than it went before. That's because I had set the value to 0. We'll just leave it at that for the time being. I think we're running low enough on time. If you do download my source code I had for this, I also added in a little bit of randomness to it. So we had a random height as well as some physics, but I think we'll leave it at this. But the other value, the last thing I did want to show you for today was I had that new variable I created for speed. And you see when I come back over here to Unity now, if I go to my Meteor, I look at that script we added it, all of a sudden it has a new property to it. So it now has that speed variable that we just created back here. It's now publicly exposed in the editor. And I don't ever have to go into my code again in theory. I can make this thing go way faster at like 50 instead. And when I hit play, you should now see it. It's moving really, really fast going by the screen. But again, the power of this, especially if you're working with a team that's not all programmers, they can come in here, interact with these variables directly in Unity. They don't ever have to use Visual Studio or touch any of your code. So in theory, you could do that for every single variable you ever write, and your programmer or your designers rather can come in here and just mess with stuff all day. So I think we'll leave this demo here for now. Like I said, it's only an hour. I used to teach a Unity intro course, and it was an entire course. It's not just the 1 hour session. So we didn't get too far, but I did promise you a few resources. So I do want to go back to that real quick. So I will post these all here in the chat as well. You have them all, and then let's talk about them real quick. Like I said, Unity Learn. We only had 45 minutes or something like that of Unity. You probably didn't even have it downloaded by the time I went through that all. But if you do want to get some more experience before the game jam starts this weekend, or just in general, definitely check out Unity Learn. It's free with your Unity account. Like I said, it has courses for a whole bunch of different stuff: programming, creating art, dragging and dropping, using the editor, whatever. It's got it all in there, or a whole bunch of stuff at least. The course I would suggest you check out in particular is this Create with Code. This is really the Unity 101 course. In fact, the first project you're going to create in that is something similar we did, as we just did to today, where I think it's a pickup truck and it drives left and right. It's in 3D this time, but you're avoiding some obstacles. It's got videos and steps, like literally every single step you'll have to take to create the project. It gives you the assets for it as well. I highly, highly suggest checking out the Create with Code if you've never used Unity before. Like I said, the meteor and the spaceship we had came from this Kenny Game Assets website. Oops, clicked when I shouldn't have. Definitely check out that site as well. It has loads of free resources, 2D, 3D. I think there's some audio on there as well. It's all free to use, open source. You don't even have to give credit, so it's really handy if you're prototyping stuff, or maybe you're working on a project externally. You're not an artist, like I'm not an artist, and you just need something placeholder. You could definitely use that. And then I also do have that. What I was just working on today. It's a few steps where we just got, but I will give you that GitHub repo as well, so you can download it in case you missed it, because I was going pretty fast today. Besides that, I just want to say thank you and open it for questions. I hope you all enjoy the game jam this weekend. I have some time. I can stick around for a few minutes here, as long as you're good with that, Rena. But if anyone has questions during the weekend, all right, thumbs up, that's good. If anyone has any questions during the weekend or leading up to the event, I am on the Discord for the event already. I'll introduce myself on there again. Feel free to reach out. Just say like, hey, I'm interested in learning Unity. Can you suggest some stuff? If you have a specific question, I'll be around most of the weekend. You can ask questions there. I know we have mentors both from the university and from Ubisoft. They'll be there pretty much the entire time the jam's on as well. So I won't be there in person, unfortunately. I'll be on the Discord, but I know I have a lot of my counterparts that'll be there. We're pretty much all Unity programmers, so we'll be able to answer questions. Also, feel free to reach out on LinkedIn. I don't often answer questions directly on there just because I'm not on it enough. If you do have questions, please use the Discord, but feel free to reach out and link. If you have any career questions, or you're looking for advice on maybe how to get into the industry, anything like that, whatever you want to chat with, just message me. I'm happy to answer questions. So at this point, I will open it. I'm trying to check out. Nathaniel asks, what's a serialized field? That's a pretty specific question. It's not really an advanced question, but I'm going to skip it for now. Please message me on the Discord though, and I will explain it, and I'll send you some documentation for it. I just think it's probably a little bit past where a lot of people might be right now. But Nathaniel, yeah, like I said, please reach out on the Discord, and I can give you some help on there. Someone right under that as mentioned it about being displayed. Pretty much gave the answer already, so perfect. Let's see if there's any other questions. I don't see any other right now, but if you do have any, please, I'll stick around here for a few minutes. Please feel free to put them in the chat. And if not, like I said, Discord's always open. Hopefully, especially on the weekend, I'll be around and able to answer your questions. I know a lot of you are students. I was a student, 10 years ago or something like that as well. I'm happy to share career advice or portfolio advice. Anything really, just feel free to ask. There is a side question here. Let's see. Side question is, do you need to use time.delta inside fixed update, or does fixed date update already make physics stuff frame rate independent? If so, what's the point of time.fixed delta time? So you should still use it in fixed update. So to give everyone a little bit of context here, it's something we didn't touch today. So if you're very confused, don't worry about it. We have that built-in update function we are using. We are putting anything in there. what happens in video games though is often what we see drawn to screen and what's being calculated in like the physics world aren't tied one to one. So even though we might be getting like 240 frames per second, let's say like a really fast frame rate, most likely because of performance, we're not going to update the physics world at that exact same speed. Instead, we try to have what we call a fixed update. So I think in Unity by default, it's every, I want to say, zero point 0.2 of a second, something like that, that it updates the physics world. And again, that's just performance based. So we can choose when our code executes if we should put it in the update or the fixed update function. Again, this is a little bit more advanced. So if you have no idea what I'm talking about, just don't worry about it. But what's the point of that? Yes, if you are in fixed update, you should still put it there, because even though it is a fixed update and there is that, what was it, time dot fixed delta time, it's not always guaranteed to be exactly the fixed update, right? You think of a computer, there's always a million things going on under the hood, right? You might have like a virus scan running, or Google Chrome's hogging a whole bunch of resources, or you're running like 4 instances of a game, whatever it is. The chances of your computer being able to execute code exactly down to like the millisecond that you think is going to is practically zero. So even though we want it to run at every, what did I say? I think it was 0 0.2 seconds. It's probably going to be like 0 0.2 0001 or something like that. It's never going to be exactly perfect. So you're still going to want to use that time dot fixed delta time to get that value, even though it seems like it should be more or less stable. It's going to be a little bit off, always like that. Hopefully that answers that question. Someone asked, how do you create a sprite programmatically? You can do that. Again, it's a little bit of an advanced question here, but you can actually create a sprite and then fill in pixel value. So you can imagine a sprite or any 2D images, like an array or a grid of like little light bulbs essentially, and I could just change the color of that light bulb, and then I put enough of those together and I get an image. It's kind of like how a TV works, right? Or a monitor. Sprites are the exact same. You can go in through Unity and actually change the values of each of those pixels and assign it to something. You could like take one texture and copy the values over to it directly. Again, it's not a question I can answer quickly or easily and tell you how to program that, but I can send some documentation if you want to do it. It's definitely possible. I've done it in Unity. I'd be interested to know why you're trying to do that, because that might change the context of the answer I give as well. Another question here. How do we adjust the camera and canvas to cover the whole display? Maybe a little bit of clarification. I'm not sure what you mean by whole display. Do you mean you want it to be like a full screen? If I go back to Unity here, like you want to see this full screen to cover the entire monitor? Is that the question? If so, I can answer to that a little bit. Yes. Okay. So what you're trying to do is, so all I've shown you right now is running the game here in the editor window. If I actually went to File and then Build and Run, and I'll do this, I'll go through it, but I'd have to set it somewhere to build. Let's see if I can just show you this quickly. I can actually build this application to run as a standalone, right? So if you're using Steam or you're playing on, sorry, just pull it here, you're playing on like PC or you're playing on Xbox or whatever, you're playing a Unity game, you're obviously not seeing this editor. You don't see all these other windows. You just see what's happening here. To get to that point, you have to create what we call a build. In this window here is where you do that. You can set up all your different scenes and everything you want. Again, it's a little bit advanced for this, but when you hit build, it will actually create an executable file. So like an exe, the actual game you play. And when you run that, it will automatically be full screen. However, if you want to see, I guess, a more full screen like in the editor, when I go into my game view here, I can change this. Let's see, where is it? I want to do full screen. It's something I changed a million times, and now I can't find it. Here we go. And where it says play focused, you can change this to be play maximized, and it's not going to take up the full screen, but when I do hit play here, you'll see it takes up more of the screen. So again, it's not perfect one-to-one at this point, but it will fill up more of your screen. And then when you hit the stop button, it'll go back to that. So some people like to use that play maximized. I usually keep it to play focused. Hopefully that helps a little bit with that question. Let's see. Question about if you hit a button, you want a bullet sprite spawned into world space. Again, a little bit outside of this, a quick question. I have a strong suspicion you're working on something in particular here. You have an idea already. You can spawn things in programmatically using the instantiate call. Again, Nathaniel, if you want to message me after, I can send you some documentation. It's not hard to do necessarily, but instead of me just sitting here trying to explain how instantiate works, I can probably send you like a 2-minute read and you'll figure it out. Let's see if we have any more. Rena has a question. If the display is large, example, aspect ratio of 5, that must be like an ultra wide, I guess, like a real wide monitor. Excuse me.
Yeah.
Yeah. Is this a setup you personally have?
Yep.
Okay, good question. So if
Well,
we have an
not
ultra,
personally, but Dal has.
okay, so if we see those, so if we have like an ultra wide monitor, we have a weird aspect resolution, but the game was originally set up for a smaller display. How do we expand on that play space? So I believe by default it will actually try to stretch to that screen size. Sometimes create some very interesting issues though, especially when you get to UI. UI is a beast in its own, but to try to help, what I will say for everyone is if you're back here again in my game view, at the top right now it's set to free aspect. That'll be the default value that it goes to. And that really, what it kind of does is like, you can see as I stretch and move things, it displays more or less, which is part of the problem we are just talking about. If I have an ultra wide and I set up for it to be like really wide and then someone plays on an old like 4:3, I'm not going to see things correctly. But what you can do is if you know the aspect ratio you're going for, as you do in this instant, I'll drop down this free aspect window. I'll go down here to the bottom and I hit that little plus button, and I can actually create a base whatever it was. So you had like 5,000 something. I could put that in by like whatever it was, 1080. Oops. Uh, and I could name it like Rena's cool monitor or something like that. Getting those awesome monitor resolutions, and you see now the screen here is set up to be whatever resolution we want it to be. This is really actually valuable for mobile development as well. Pretty much every phone has like a slightly different screen size, which could be really annoying to work with. I could come in here and put a whole bunch of different ones. I'm like, hey, my iPhone uses this, my Android's this, my Nokia's this, whatever it is. You can set them all up there as well. You'll see it does have a bunch of default ones for popular screen displays. So most of us working on a regular monitor these days is 16:9. So if I clicked that, this isn't based on resolution in terms of like per pixel, but it gives me the proper aspect ratio. So I do recommend using this if you're trying to create a PC or like a console video game. But yeah, hopefully that's a very specific answer for that monitor setup. Hopefully that helps. All right, let's see. Someone says, I guess more of a comment, that deploying a multi-platform game sounds like a nightmare. Let me tell you, it is. It's actually got a lot better these days, thanks to systems like Unity. We didn't get into it today, but obviously you can create UI, and you could do something like anchor where that UI is. So instead of just being like, hey, put my whatever it is, score or my text on screen at this world position, you can say like anchor it to the left side of the screen, but 5 units over from that or something like that. And then it doesn't matter how wide I scale my screen, it will kind of adapt for that, but it still creates obviously a lot of issues. And then we get into the whole thing of like, it's quite common these days that a game might run on a phone. Look at something like PUBG or Fortnite's a great example. Fortnite's in Unreal instead of Unity, but same issue. It runs everywhere from a phone all the way up to like a high-end PC and every console and every platform in between. So you have to manually go in and create settings, and maybe you have a really high fidelity 3D model for the high-end PC where you have to dumb down like the vertex count or how complex that model is for your phone. You might reduce your lighting. There's a whole bunch of things you could either add or subtract to try to help those instances. But yeah, it takes a lot of work by a lot of people. It goes multidisciplinary, from artists creating literally different models for each device, lighting artists coming in and changing it, trying to always maintain the same look and feel while running almost different games, really. So yeah, it is a pain. Um, All right, I'm not seeing any other questions come in, and we are a little bit over here, so I think this is probably a good time to wrap it up. Again, if anyone does have any further questions, please reach out on the Discord this weekend or before, and I could try to send you over some help. And reach out on LinkedIn as well if you want to connect. I know a lot of you are probably looking for jobs in the upcoming years, and it's a good idea to start building out that networking portfolio, if you will, as long as your own project portfolio. And doing a game jam like you're about to do this weekend, hopefully, take that project and put it on that portfolio. It might not feel like that significant of a game or a project to you, but the fact that you sat down and created something in 48-ish hours, you worked with a team, you're able to actually create something from concept all the way to production or a finished product is a huge thing. It truly is. So many students will come to us or to any game development studio and be like, "Hey, can I have a job? I studied programming. That's it." I'm like, "Oh, what have you made?" "Oh, nothing. I created a calculator app." Great. There's so many people. It's such a competitive industry. You're going to need that experience. You're going to need to show you've created projects on your own. And again, if you can show that you've gone from concept all the way to production or a completed project, it really does speak volume. So take this weekend, have fun with it, join teams, meet new people, learn skills, do all the things you expect. And then when you're done, take that project. It doesn't matter if it doesn't look that great or it's kind of buggy or whatever it is, put it on a portfolio, put it on Itch, put it somewhere that I can access it if I'm trying to hire you at some point. That's probably my biggest advice I'd give to anyone doing a game jam. Don't just do the jam and think it's done. Use it. Use it to your advantage, please. All right, cool. Rena, was there anything else we needed to discuss or share or anything like that before I jump off?
Just wanted to remind everybody that there's one more tutorial tomorrow on VR with Myra, and that's taking place in the Goldberg building or online. So please come and check it out, especially if you want to do a VR game during the jam. The workshop is actually at 12 p.m., and you'll see it here in the Goldberg building. So come on down if you want to learn a bit about VR. And I just wanted to say thank you so much to Ben. As you all can see, he's an incredible resource and very great teacher. Even I'm asking him questions. So a round of applause for Ben.
All right, thank you, everyone. I'm honored to be out, and hopefully I can help you this weekend. And like I said, ask questions, or I don't even care if it's a question. Just be like, "Hey, I made this cool thing. I want to share it with someone. I want to see what you made," and I'm not there. So, all right, thank you, everyone. We'll hopefully talk soon. Enjoy the weekend.
Thank you.
Bye.